for loop gives you an example. For each loop also gives you an example, and so on. While loop, there's also something called while loop. It also gives you an example. So these are different types of loops. So I'm basically going through this kind of basics with you, and there are a bunch of tutorials here. If you are more interested in, you can go through this. This looks okay. This looks like an interesting website. I just happened to be there. I can have a look. Okay, so I'm not going through all the other loops because we are going to use for loop today. That's enough. Value types we went through. Okay, value types there. Okay, so maybe this is last thing. Yeah. One more last thing. Value types. So there are two value types in C#. One is called value type and one is called reference type. And this, to understand this is quite important. And this might be confusing a little bit, but once you understand that, you might be able to detect some weird errors in your script by understanding this. So for example, if you have A and say B is A, and then if you assign a new value to A, imagine what should be the value of A and what should be the value of B. So I can clearly tell that A is 12, and because I changed A to 7, so A should be 7, that's for sure. But B is A, and what do you think B should be? Because now B became 12, and then it got copied. So even if you change A, it doesn't change the value that is assigned here. So B should be 12, right? Let's see if that's true. So A is 7, B is 12. That's pretty easy to understand, right? But there's an interesting thing about point 3D happening. Let's say point 3D is a C. New point 3D. New point 3D 0, 0, 0. And then say point 3D D is C. And then I'm going to do something to my C. Maybe I just change the Z value to 1, for example. So definitely C became 0, 0, 1, if you agree with that. But you will see that actually D, in theory, if you understood this one, D should be remaining at 0, 0, 0, and C should be remaining 0, 0, 1. Let's see if that's true. Okay, so this is actually changed. Okay, so yeah, so I forgot. So okay, so this is understandable. So in Grasshopper Rhino, point 3D is a value type. That's why it actually stored, so it made a copy. So instead of referencing it, and made a, even if you change the C, it doesn't store to D. So these two values are value types. So this is value types. So this integer is coming from C#. This one is coming from Grasshopper. But in different programs, for example, in Unity, if you're coding the same Unity script in C#, in C#.3 is reference type. So you may get confused by that. But okay, so this was, let's say, we can write it here. But this is really important to understand. So let's say we have a list of, because list is reference type. Reference type. So list of, let's say, string A, B, C, D, E, and F. E, new list of string is hello, hi, and hi again. So there are two, sorry, it should, so this is new list and adding a value to this list like that. This is same as adding E0 is high, E1 is high again. So if you want to rewrite this, you can say E0. Oh, sorry, E add high. That is same as this, but to make it into one line, I do that, yeah. And then there is list of string, Control C, Control V, E, F is E. And then after this, I will make a change to E0 to something by. So in theory, if it follows this logic, it should, this E should be high, high, E should be high and high again, and F should be high and high again. But E, E, F. But this one, so you notice these two are all different because it stores the original number or value and doesn't get refreshed. But this one, you notice that they are pointing to the same thing. That's why it's E is same as F. So that's why it's important to understand that list is a reference type. So there are a few things that are specified. So for example, whatever is reference type is called struct, and whatever is reference type is called struct, and whatever is value type is called, no. So value type is called struct, reference type is called class. So list is a class, this is a reference type, and point3d is a value type, int is struct. Struct is a value type, and it's important to understand where but this won't give you too much problem at the moment, even if you don't understand this. But if you understand it, you can easily detect some problems in the future. And if you Google something like value types and variables, and actually these were explaining. So this says these are value types, and int, you can see the int, float, double, all of these are value types. And reference types are, for example, class and everything. And you can also check from Rhino command to see if whether I am a class or a struct. So you see that this is a struct. That's why this is a value type. So if you see something, let's go see if there's anything that are class types. So if you are not clear, you can come back to this Rhino command and check whatever the program is providing, that class is, whether it's struct or a class. Let's see if there's anything. So this, you see, this is a class. So class meaning that it's a reference type. All right. So that's I think that's the last concept, and we can go ahead and build our example file from now. Is everything okay? Can we have a 5 minutes break? Okay. Everybody still hanging in there? All right. Let's come back in 5 minutes. Now it's 7:58 here. So 8:05. 7 minutes. Okay.
Okay.
Thanks. I'm going to just create random points without any movement, but I'm going to set these. So creating all points and create these many random points and output all these points. So randomness, random range, we don't need it. We need the bound size and the point size. Okay, so I'm going to hide this. So this is a preparation for our next exercise. So this creates a number of random points for us. Yeah, we don't need this one. So this is our first usable plugin. So we don't need this. So we can delete this. Here, what we need is we need to input a bound size. So type int and point count. So how many points? And int. So bound size should be a double. Bound size should be a double. And we should delete this instead of having it because we are going to input from outside. Okay. So this is a useful function for us, which creates a random points for us. But random, new random. But why this is empty? Oh, because we don't have any value here. Okay. So we are going to make bound size of 30.00 and 50 to, we can make it up to like thousands or something. So we are going to make 500. Okay. Change the number. Okay, so we are going to use this as a starting point of our next exercise. And we can package this saying random points. So this you can, in the future, you can copy paste to any other thing, and you can, this is quite useful. So I always just package this and use it somewhere else. So for our next exercise, we can just use these as an input starting point. So we can change this slider and numbers. Okay. So let's go ahead and build our first exercise. Okay, one more thing I want to add here is whether this is creating a three-dimensional or not. So let's add some value here, but only if my input Boolean value is set, it says true. So if this is false, it's still 2D. So is 3D, and say only, and type int to be bool, and only if this is 3D, if Boolean, I will make a three-dimensional, else I remain this as two-dimensional. So just copy, paste, and just change this to Z. Just add one more value to Z. So here you can say, you can see if it's true, becomes 3D. If it's false, becomes 2D. 2D just easier for us to detect things in the future. Okay, so that's great. Yeah, so this is creating a random points. And let me show you how we can actually use this in a very interesting way. So I'm going to use these as points, but use these as vectors. So for them to be able to become my vector, bound size should be 1. But this gives me in like that. So I need to move it down. So instead of having my bound size from 0, 0, and minus times 2. So what I'm going to do is I'm going to move this to here instead of just having in a positive position. So just times 2 and minus another bound size for all of this. Okay, so it's going there. So in this case, I need to change this to 0 to 0 0.5, 0 0.5 in order to make this into 1 into 0 to 1. But that's okay. Anyways, I managed to make this into a non-positive value. So maybe we should also make this into that. So you can also just copy paste. You will notice that they will move from here to there. Somewhere like move 50, 50. So that's the idea. So let's do that by deleting this. And change this to 50. And toggle. Does it make sense? Just make it into something that you can have negative value as well. Okay, so now what we can do is just by changing this value, we can use this as direction and use this as points. So hide this display, and because I have exactly same points, we should use the same points number, and you use displayer, so vector display, and use them as their anchor point, and use these as a random points. Yeah. So to be easily to pair this and see what's going on is by adding this in a C# script to see if they're doing the things. So these are points, point 3D, and these are vector 3D. But what we didn't do before is that because now this is a list, it's not anymore only one point. So you need to change this type int to list access. Change this type int to list access as well. So you'll see that there are lists of point 3D and lists of vector 3D. Yeah. So all PTs, all directions. I'm just separating the point creation and vector creation and try to just animate it. So I'm just going to simply let them add to each other. So if reset, let's not even talk about reset. Let's just go through them. For int I is 0, I smaller than the count, I plus plus. And you can actually get the I of it, and is plus is all directions I. That's it. So we add a timer here. Move. And oh, because because we didn't output it. 4 points. I see, because it's not really refreshing. So yeah, because it's still getting the original points. So we should do list of points. Point is new, list of points. All new points, and for new points only if new points count is 0. So when there is nothing, new points is all points, else. So let's see if this works, because it's a reference type. Maybe it doesn't work. It's not working. So what we should do is we go through each of this, go through all the points and say create a new point 3D PT is, and add that to. Don't worry about this part if you didn't follow that precisely, but this is just a demonstration that I want to show you how these two can link together. Okay, so, and this should be outputting the new. Okay. So what we want to show is okay. So you see this green geometry is literally something that came from before. So recompute. So you change some, because we didn't put a refresh button. We can do that, reset instead. Add a reset button, which is a boolean. A button or a button. Yeah. Okay. So whenever what is the error message? This was our okay. Because I need to refresh this, so I need to make them clean. Okay. Cool. So they are actually keeping their original random point, random vector. So they're keeping the random vector and they're pointing out. So you notice that they're always keeping coherence towards the outside. It's because their random seed is not different. So that's what I'm assuming. So I'm going to force this random seed to be different for both of them. So now you can see that they are a bit more random. Okay. Okay, so let me just have this random seed as an input value, so you can use this later.